In this video, I'm going to go through two example problems from the assignments in Khan Academy that have to do with rotating 2D shapes in 3D. So we'll take the following two-dimensional shape, which is a triangle, and we're going to spin it around this line M. Okay, so what's the 3D shape that happens when I spin this around line M? So if I imagine this point rotating and spinning around the line to become three-dimensional, it would rotate like this. This point, since it's already on the line, is going to stay right where it is, but this point will rotate around to create a cone. Okay, so we get this cone shape that appears. And it becomes a little bit clearer if this picture isn't really helping. It becomes a little bit clearer when you use that GeoGebra link that I mentioned in the video before this. Okay, so we get a cone that results. What do we know about this cone? Okay, well, obviously it's not a cylinder, so we can cross out those first two because that's talking about cylinders. So what do we know about this cone? So does the cone have a height of 4 units? Well, actually, let me erase that writing there. So the cone, the tallest that the cone would be from this point here to the bottom, right? So what is that distance? That is 8. So that's the height of this triangle. So the height of the cone is still going to be 8. So that's not true. It shouldn't be 4. The height is 8. So then, let's see, the cone has a diameter of 8 units. Obviously, this would be our choice because it's the last one that we left. But remember the diameter from when we were talking about circles, and we see a circle cross-section at the bottom. The diameter is the distance from one side all the way through the center to the other side of the circle. Okay, so this would definitely be a distance of 8 because the radius that they gave us just from here to here is 4. So if we double that, that definitely gives us a diameter of 8. So that distance is 8 as well, and the height is 8. Okay, the other example that we'll go through is now if we take a rectangle and we rotate this around line M. Okay, so these 2 points here and here, they're going to stay right where they are because they're on line M, but the other 2 points are going to spin around. So let me see if I can do this justice when I'm drawing this, but they'll spin around. One thing that's helpful is I know that on the other side when I rotate this, it'll be the same distance there, so I'll use this kind of as like a point that I know I'll go to. There we go. Okay. So that point will spin around, it'll rotate like this, and then this point as well will spin around and rotate. Okay. To give us a cylinder. This is a really rough picture for that. Again, you can see this a little bit clearer when you use that link for GeoGebra, but we do get a cylinder that results. Let me try to make this just a little bit nicer looking. Okay. So let's examine what we know about the cylinder. So it's definitely not a cone. Okay, so we don't get a cone from rotating a rectangle. We only get cones from rotating triangles around. Okay, so it's not either of these cones. So the cylinder, let's see, does it have a diameter of 4 units? Well, I know that the distance from here to here, my radius, okay, because this is a circle at the bottom. I hope you can see that that's a circle at the bottom of our cylinder. The radius of the cylinder is 4, so the diameter, distance from one side to the other going through the center, is definitely going to be 8. So that total distance of that green line is 8. So yes, that would be true. We would pick option A. And then the cylinder has a radius of 1 unit. No, that's not true. The height is 1 unit. The height stayed the same. The height remained just 1 unit tall, and then the diameter is what happened to be 8.